A security researcher sent an email to an AI assistant. Inside that email was a hidden instruction. 5 minutes later, he received a private encryption key from the machine that assistant was running on. Not a theoretical attack, not a simulation, a real test on a live system that thousands of people had just installed. This is an AI clone of Ronald, and that's on purpose. AI is already part of how we work every day at our company. This channel exists to separate signal from noise when it comes to AI in business. If you value calm, grounded analysis instead of hype, consider subscribing. The tool at the center of this story is called OpenClaw. You may know it by its earlier names Clawdbot or Moltbot. It's an open source AI agent designed to run locally on your computer. It connects to messaging apps like WhatsApp, Telegram, Slack, and iMessage. It reads your emails, manages your calendar, runs scripts, controls your browser, and executes shell commands directly on your machine. What makes it different from a regular chatbot is that it actually takes action. It doesn't just respond to you. It remembers context across sessions, makes decisions, and carries out tasks with minimal involvement from you. The promise is enormous. A true AI assistant that handles your work, not just your conversations. That promise is exactly why the project exploded. Over 60,000 GitHub stars in a matter of days. Mac Mini's selling out because people were building dedicated home servers for it. The developer community called it the first real personal AI assistant. The kind of tool that makes you feel like you're living 5 years in the future. And here's what most of them assumed. If it's open source, the code is transparent, so it must be safe. If it runs locally on my machine, the data stays with me. If I set it up myself, I'm in control. Each of those statements sounds perfectly reasonable. In isolation, they might even be true. But together, they created a dangerous sense of false security. Within days of OpenClaw going viral, security researchers started painting a very different picture. Hundreds of instances were found sitting on the open internet. No authentication protecting them, nothing. A researcher at a red teaming firm scanned the web and found exposed servers in seconds. Not through hacking, not through any kind of exploit. Through basic scanning tools that anyone can download and run. What was accessible? API keys, bot tokens, OAuth secrets, signing keys, full conversation histories across every connected messaging platform, the ability to send messages as the user, and in some cases, direct command execution on the host machine. All of it stored in plain text configuration files. No encryption, no containerization. Open to anyone who found the right address. The core issue was architectural. OpenClaw was designed for easy deployment, not for secure deployment. And when non-technical users set it up without understanding what they were exposing, the result was exactly what you'd expect. Now think about what this means in a business context. Those API keys are not just strings of text. They are financial instruments. They connect to cloud services that charge by usage, language models, compute infrastructure, third-party integrations. When someone steals your key, they can run up your bill, hundreds or thousands of dollars, and you won't know until the invoice arrives. That's the mild scenario. The deeper exposure is access to your email, your messaging, your calendar, your internal tools. An attacker with those credentials doesn't need to break in. They don't crack a password. They walk through the front door, the one that was never locked. My company builds AI automation and voice agents for businesses, restaurants, service companies, operations that depend on consistency and trust. So this is not abstract to me. When we connect AI to a company's phone system or scheduling, we're handling real customer data and real revenue. The difference between a properly secured system and an exposed one is the difference between a tool that works and a liability quietly ticking in the background, which is exactly why the next layer of this story matters even more. The exposed credentials were only the most visible problem. Underneath that sits something called prompt injection. This is where someone crafts a message, an email, a chat, a social media reply that contains hidden instructions meant for the AI agent to follow. The agent reads the message. It processes the hidden command as if it were legitimate. and it acts on it without your knowledge or approval. In one documented case, a security CEO sent a carefully constructed email to a live OpenClaw instance. He then asked the agent to check its inbox. The AI read the email, followed the embedded instruction, and sent back the machine's private encryption key. Total time, 5 minutes.
This was not a state-level cyber attack. It was a social engineering trick aimed at a machine instead of a person. And the machine complied without hesitation. When an AI agent has shell access, browser control, and file system permissions, a successful prompt injection is not just an embarrassing leak, it's full system compromise. If this is changing how you think about AI agent security, a quick like helps other business owners find this analysis. But the security community wasn't the only group watching. When the project was forced to rename, first from Clawdbot to Moltbot and later to OpenClaw, there was a brief window of confusion. Account names were changing, repositories were migrating, and the founder made an error during the transition that cost him temporary control of his original social media and code hosting accounts. Scammers moved within hours. Fake accounts using the old Clawdbot branding started promoting a crypto token called Claude on Solana. Retail traders, caught up in the hype around the AI tool, bought in fast. The token hit a market cap of $16 million. Then the founder publicly denied any involvement. He stated he has never issued a token and never will. He called every related crypto project a scam. The price crashed over 90%. People lost real money. Not because of a software vulnerability, because hype traveled faster than verification. That's a pattern worth understanding deeply. When something goes viral in AI, the window between excitement and exploitation is dangerously narrow. Someone will fill that gap. Usually not with your interests in mind. And here's what makes all of this relevant far beyond a single tool. OpenClaw is not going to be the last AI agent that promises to run your work and your life. This category is accelerating. Personal agents that take real actions, remember your context, and integrate with your existing systems. Every single one will face the same fundamental tension. The more useful the agent, the more access it needs. The more access it has, the larger the attack surface becomes. Cisco's security team tested OpenClaw's skill system, basically third-party plugins, and found critical vulnerabilities. One skill they analyzed was effectively malware, silently sending user data to an external server while bypassing the agent's own safety guidelines. And InfoStealer malware, the same kind that already targets your browser passwords, has been specifically updated to harvest OpenClaw configuration files. The criminal infrastructure has already adapted to these tools. This is not a future risk, it's a present one. So what does this actually mean for you as a business owner or operator? 3 things. Convenience is not security. Running something locally does not make it safe by default. Your configuration, your access model, and your understanding of what the tool touches, that determines your real risk. Credentials are financial assets. API keys, tokens, and OAuth secrets deserve the same protection you'd give your bank access. When they sit in plain text on an internet-facing machine, they are unlocked cash registers. And speed kills security. When adoption outruns review, the early adopters are usually the first to pay the price. Not because the technology is bad, because the gap between capability and caution is exactly where things break. I'm genuinely curious. Has your team had a real conversation about what it means to give an AI agent broad access to your internal systems? Not the marketing pitch, the actual risk assessment. Drop your thoughts in the comments. I read every single one. If you want more calm, grounded breakdowns of how AI plays out in real businesses, subscribe so you don't miss what comes next. Security is not about avoiding new tools. It's about understanding what those tools touch, what they control, and what happens when the setup isn't perfect. That's the difference between using AI to move your business forward and letting it quietly become your biggest blind spot.